Hello and hi everybody. In this video, I'm going to talk about subtopic 4.2, Newton's law of motion. I'm going to focus our discussion on just 4.2a, which states Newton's law of motion. Sir Isaac Newton introduced three laws of motion. The first one is Newton's first law. Second is Newton's second law, and the third one is Newton's third law. Newton's first law states that if there is no net force acting on an object, the object that is at rest will remain at rest, or an object that is moving will continue to move in straight line with constant velocity. No net force here means that the vector sum of the force acting upon an object is equals to 0. Newton's first law is also called as the law of inertia. So what is inertia? Inertia is defined as the tendency of a body to resist change in motions. In the simplest words, we can say that the object will keep doing what it is doing. Inertia depends on the mass, so means a bigger mass needs a bigger force to overcome its inertia and change its motion. Let's look at some example. I said that before, when an object that is at rest will remain at rest, say the rock will stay put and the water bottle remain at rest on the table. If we don't apply any external force on this object. Take another example such as we can see on the table there is a ball sitting on the table. If it is not moving means it will stay at the same position. To push the ball across the table at constant velocity, it requires a force from our hand that can balance out the force of friction. So, when the object moves at constant velocity, means the pushing force is equal in magnitude with the frictional force but acting in opposite direction. So, the net force is 0. When the ball here hit the book, it is clearly seen the ball moved to the left and now it stops. It is clearly seen that the moving object do not change their direction unless any force causes them to move from their path. In summary, an object or particle is said to be in equilibrium when the vector sum of all forces acting on a particle or object equals to 0. Mathematically, we could write down as summation of F equals to 0, and then it is more easier to work with the equation in terms of its component, which we have summation of Fx equal to 0 and summation of Fy equals to 0. There are two types of equilibrium of particle. We have the first one is static equilibrium when the velocity is 0. So that means the body or an object is at rest or stationary states. The second one, we have dynamic equilibrium when the acceleration is 0. So means the body or an object moving at a uniform or constant velocity. Now, let's proceed our discussions to Newton's second law. Newton's second law states that the rate change of momentum of a moving body is proportional to the net force and is in the same direction as the net force acting on it. Mathematically, it can be represented by summation of net force is directly proportional to the rate change of momentum. Newton's second law also can be written as summation of net force equals to the rate change of momentum, and we know that the momentum is equals to mass times velocity, then we could write down as dmv per dt. Expanding this equation, make it summation of net force equals to velocity dm per dt plus mass times rate change of velocity. Assuming that dm per dt is 0, therefore we just have summation of net force is equals to the mass times dv per dt. And we know that acceleration is equals to the rate change of velocity. So finally, we get that summation of net force is equals to the mass times with acceleration. Actually, Newton's second law tells us that when the net force acting on the object is not zero, means the object will accelerate. And the direction of the acceleration is in the direction of the net force acting on it. So for example, if you drive a car, so you have force to the right, which is 10 Newton, and at the same time you have force acting to the left, 7 Newton. So when you calculate the net force, so you have 10 minus 7, and you will get the net force is 3 Newton to the right. So your car will accelerate to the right in the directions of the net force. We have equation F equals to ma. Then when we rearrange, so we get acceleration is equals to summation of net force divided with m. So we could see the relationship that acceleration is directly proportional to the net force acting on it and inversely proportional to the mass of the object. So we could understand that heavier object requires more force to accelerate and lighter object require less force to accelerate. Okay, now look at the Newton's third law. Newton's third law states that for every action force, there will be reaction force that is equal in magnitude but opposite in direction. What means by this statement? Okay, look at this first example. When we push the wall, that is the action force that we do. At the same time, the wall will react and push back our hand with the same magnitude of force but acting in opposite direction. Let's look at another situation. When you are a baseball player, the action force is when you hit the ball using the bat. The action force is when the ball reacts on the bat. The force are in equal magnitude but acting in opposite direction. When you have two bodies interact, the action and reaction forces act on different bodies. They do not cancel out. Thinking about a car hitting a brick wall. The car exerts an action force on the wall, and the wall exerts a reaction force back on the car, bringing it to stop. These vectors are equal in length but pointing in opposite direction. So whenever we have an object exert a force on a second object, the second object will exert equal force in the opposite direction on the first object. There can never be a single isolated force, and forces always come in pairs. As a summary, Newton's first law gives us an idea an object will preserve its state of motion when the net force acting on it is zero. Newton's second law states that when the net force is not zero, means the object will accelerate. Mathematically, you could write down as F equals to ma. Last one, Newton's third law states that for every action, there is an equal magnitude of reaction force but in opposite direction. That's all our discussion in this video. I hope this will help. Thank you for watching.